Okay, today we're going to be going over my midterm project for EDCI 411. My name is Jason Lauritzen. The lesson I'm going to be teaching today is transformational geometry, specifically reflections. Okay, so the first thing we're going to take a look at, I would have this up on the board, is kind of a plain Jane workshop model lesson plan. I'd actually have this part with the whole thing up on the screen for the kids to see. So lesson name is Reflections. It's in Unit 8G, so 8th grade geometry. Has our objectives. Students learn that the reflection is its own inverse transformation. By the end of the lesson, students will be able to reflect a shape across a line on the coordinate plane and understand the 4 rules of reflection. Our Idaho Math Content Standard is Geometry 8G, understand congruence and similarity using physical models, transparency, or geometry, but it's specifically verify experimentally the properties of rotations, reflections, and translations. And then it's kind of off the screen here a little bit. We have our Idaho Mathematics Practice Standard is going to be number 2, reason abstractly and quantitatively. So looking at how our lesson is going to be laid out here, we're going to start out with the intro. That's basically what I'm doing now, talking about what a reflection is and kind of giving an overview of the lesson. This is the overview part. Once we get done with the intro, we're going to go through a mini lesson, which is going to be me walking through the reflection slides, the 4 rules of coordinates, and then giving some examples. I've got a couple mini games for reflections and coordinates. The games I found online aren't very good, but there's something as kind of a placeholder so I can show you how this lesson would go. I would use whatever my school's curriculum uses for computer math games. I know they have some on these standards for iStation, etc. While the kids are playing the games, I would be walking around, spot checking, seeing how they're doing, work with them individually to get them back on track. If they weren't getting it, or there seemed to be a lot of people missing some of the concepts, then I would do a group reteach once again up on the board. I'm going to be doing it on here on some online grid paper. Once I did that and got them back on track, release them again, go back to practice, play the mini games again, and then we would end this with taking out our math journal and writing about the concepts, in your own words, how exactly this is, maybe what problems you had with the concepts, or I do a lot of stuff where I just do keywords of things that will remind me how this works, talking about folding across a piece of paper or a line, using the line as the fold in the paper. Okay, so now that I kind of gave you an overview, let's hop in of how this would actually go. So first we'd talk about what is a reflection, and it's pretty cut and dry. In geometry, a reflection is a mirror image of an object or function over a line in the Euclidean plane. We most frequently use the y-axis, the x-axis, or the line y equals x, although any straight line would work. A reflection can be thought of as folding the object over the line of reflection. So we can see here, this is a pretty good indication of what exactly we're doing. We have this triangle on the left side. We are reflecting it across the y-axis, and it's basically like we're folding the object using that y-axis line as the fold. If I was teaching this in person, I would actually have a folded piece of paper, show them how this would work. You could do it with a transparency, thin paper that you can see it through, and basically demonstrate how it would look going across the y-axis, how it would look going across the x-axis, and then we could do the y equals x, also showing them how a diagonal would look. At this point, I'd be doing that modeling with the paper. The next slide we're going to go over the 4 rules of reflection. So this is one of those old school things that I learned when I was a kid. We've updated this a lot since then, but it's a shortcut basically. Most of my math teaching goes back to logic. These are great shortcuts, but as all of us know, if you're memorizing them for a test, go ahead and do it. If this is something that you want to remember 2 years from now, unless you have an eidetic memory, it's probably not going to happen. Much like, exponent rules. I don't remember a lot of those. Most of you won't, in a year from now. But if we have the basic concepts and the logic behind it, it's something that we can all recreate for ourselves for use at that time. But we're going to go over here. So the coordinate rules for reflection. Reflecting across the x-axis. So if we look here, it's x, y becomes x negative y. Reflection over x-axis, when reflecting across the x-axis, we keep the x the same, but make y negative. And then on the board, I would show this because we have, when you're folding it, when you're reflecting across the x-axis, your y values aren't changing. Only your x values are changing. X-axis. Your y values are changing, your x values are not. And then looking at the y-axis, what I was picturing in my head when I was saying this, reflection over the y-axis, when reflecting over across the y-axis, we keep the y the same, but x negative. That's because when we're folding along the y-axis, the x value is changing, but the y value is staying the same. And then reflection across y equals x. When reflecting over the line y equals x, we switch our x and y. And we'll show in a minute why that makes sense. I would model this with a piece of paper once again, that because you're reflecting across that diagonal line, that it's actually swapping values with the x and y coordinates. And then reflection across y equals negative x. When reflecting over the line y equals negative x, we switch our x and y and make both negative. And we'll also see why that makes sense here in a minute. Okay, so switching screens here a little bit. So we're going to play with these concepts. Okay, we've got this is just an online virtual graph paper. It lets us play a little bit here without being really structured, but we'll walk it through. So the first thing, let's look at that fold across the x, reflecting across the x-axis. Let's grab a line here and let's draw ourselves a triangle. So we've got the triangle here. The 2 main ways to do reflection is we can look at it logically, right? We can picture this with our minds how we would do it. Let's grab a different color here for our reflection, and let's go. We're reflecting across here. Okay, so if we're reflecting across this line, we're pretending that this x-axis is a mirror. So if we're looking across here, this line is 1, 2, 3, 4 away. So we're going to draw our same line 4 away on this side. And then if we're looking that this point is 8 away from the x-axis, the corresponding point is going to be 8 away on the other side of the x-axis. Once we have our 2 lines, we know they're in the right place, we can finish our triangle. So that's reflecting across the x-axis. Pretty straightforward, but that was just, as I said, doing it logically. We're picturing this in our mind of if this was a mirror, if we're traveling 4 away from the mirror this way, we're going to travel 4 away from the mirror this way. But let's look at our coordinates. So look at our rule. So our original here, we've got 8 and 8, so we've got 8 for the x value, 8 for the y value. And then we've got 8 and 4. So we've got 8 and 4. And we've got 4 and 4 for our other point. Okay, so what was our rule for going across the x-axis? Let's go back and take a look. So our x-axis rule was, if we have x and y, it becomes x and negative y. So let's go over here and double check. So this is x and y is 8 and 8. If we were going to find this point over here, the x value stays the same, right? And the y value becomes negative. So that, using that rule, that would be 8, negative 8. This one would be 8, negative 4. And this one would be 4, negative 4. And let's take a look here. Okay, so now let's double check. We just used that rule from our original, the 4 rules of reflection, coordinate rules, and let's double check and see if we're right. So this one, this point, which is the corresponding point for here, we went from 8, 8 to 8, negative 8. This is 8 and negative 8. We're right there. This is the corresponding point reflected across the line. It was 8, 4, and now it becomes 8, negative 4. Same thing here, 4, 4, 4, negative 4. Look at that, our rule works. I don't think any of us were really surprised there, but I would then show this same thing across the y-axis. I would show the same thing. We draw in a line of y equals x. We draw in a line of y equals negative x, and show those the same concepts. We would do it logically, looking at it as if the line was a mirror. Then we would also do it with our 4 rules of reflection, because those are the 2 things that we're looking at doing. So now if we go back to our original, so we did our intro, we did our mini lesson, and then we're going to practice. So I just found a couple games. We've got one, reflection, horizontal or vertical mirror line. Let's go ahead and pull it up here. It's a pretty simple game. Like I said, this is basically just a placeholder. So triangle A is reflected in a vertical mirror line. Which way around would it be after the reflection? Okay, A, would be, we're saying vertical, that's up and down, so it would be B. Okay, these shapes are reflections of each other in the mirror line marked M. Well, these 2 points are at the right place, but those aren't, so that would be false. Which of diagrams A and B shows a correct reflection in the mirror of line marked M? Once again, we're not going to have a change in size. This one, the coordinates match up. When you reflect point P in the red mirror line, what are the coordinates of the new point? So we can do this one. This one, we've got, it's 2 away. So we're going to go 2 away, and it's 1 up. We know that one's staying the same, so it's going to be 3, 1. What do you know? This is a reflection in the mirror line marked M. This is 3 away from the line, that's 2. That's going to be false. If you reflect a point A in the mirror line marked D, what would be the coordinates of the new point? We're going 1 away there. Our y value is not changing, so it's going to be 3, 2. Which diagrams A, B, and C show a correct reflection in the mirror line marked M? That one's not, that one's not, so it's going to be this one. They're trying to mess us up here. This is a poorly designed game. We've got B, B, that one shows a B. Sorry, I didn't design the game. We're just using it. Which line is the mirror line for this reflection? Well, it's Q. Once again, using P's and Q's. These are kind of a poorly designed game. I'm sorry. But let's go ahead and go back to our lesson here. So we play the mini game. I would walk around at that point, spot check, see if anybody's having real hard time with it. If we're using Ice Station or something like that, it would have, you know, I could watch in real time, see who is having a low score on the game or having trouble with it. If it's a big concept problem and it seems to be multiple people, I would then at that point group reteach the class. Let them go back, keep working on the mini game, and then we'd have our reflection. So our reflection would consist of me reiterating kind of what we were going over, suggest some reflection questions, or things to consider, like how useful they think that having those rules of reflection is versus being able to recreate them or refine them themselves. This is kind of just a down and dirty, short and sweet example of how I would teach a concept like this. I'm a little more of the old school sage on a stage, but I'm really trying to incorporate some more modern concepts and games and more fun and interactive ways to participate in the lessons. Thank you very much for listening, and I appreciate it.